Hello and welcome to another edition of Indy Labs, where we put the science in your hands. Do you ever feel empty inside? Not a cool feeling, huh? Well, I got some news for you. You're made out of atoms, so you are mostly empty inside. In all seriousness, you're made out of atoms. They're mostly empty space. It's a bit shocking when you first discover this. But in today's Indy Lab, what we're going to do is focus on the empty space that's in between atoms and molecules. Emptiness, or the void, is historically a very controversial, uncomfortable, and sometimes scary idea. In some ancient societies, arguing that nothingness could exist was something that could get you jailed, or even worse. The ancient Greek philosopher Aristotle proposed an argument as to why the void could not exist. And even though the argument's flawed, it was still pretty interesting. What he looked at was, if you took something like a container of water, and you also took a container of honey, and you were to drop a marble into both, the marble would pass through the water much faster than it would pass through the honey. His idea then branches off from this. The more dense the material, the more it's going to slow down the passing of that marble. And then the opposite would be true, that the less dense the material, the faster that marble would be able to fall. If then you had nothingness, there would be zero density. And he thought then mathematically that would reason, if you have a density of zero, that marble should fall at infinite speed. The Greeks back then already had a problem with something going at infinite speed. If you could go infinitely fast, that would mean you could be in all places at once. Therefore, in Aristotle's mind, nothingness could not possibly exist. Why make so much ado about nothing? Well, the idea of emptiness is incredibly connected to the idea of smallest pieces, atoms. Without empty space, atoms would not be able to move around. If you accept that atoms exist, you must accept that emptiness can exist as well. Aristotle was very much against the ideas of the ancient Greek Atomists. These were the first people in recorded history that ever proposed the idea that smallest pieces of matter exist. That these smallest pieces would be uncuttable, unbreakable, indivisible. They called these little pieces atomos, which is where we derive our word atom. The Atomists were led by Leucippus and his very diligent student Democritus. Well, today we're going to do a really simple experiment that Democritus I think would have loved. It's going to show us direct evidence that empty space exists in between molecules. We shall reveal to you the void. Let's talk materials. For the lab today, you're going to need a measuring cup. 2 cups is better. You can use just one, and certainly you could use metric with this as well. We need an empty 2-liter bottle, nice and cleaned out, and also remove the label. You'll need something to mark with, so some permanent marker works just fine. Other than water, which I hope you have plenty of, the most important ingredient for this is going to be 91% rubbing alcohol. The chemical name for rubbing alcohol is isopropyl alcohol. You're going to hear me say that a few times in this video. At the drugstore, supermarket, you can find it at 42%, sometimes 33%. You want to get the highest concentration that you can. And then optional, but certainly helpful, a funnel will help us prevent some spilling. And then food coloring is going to help us see our results a little bit better. So what's the idea here? Well, before we get into it, let's take a closer look at how pieces of things work. Check this out. So here I have some chocolate malt balls, and I poured approximately 1 cup as best I could considering their shape and size. You can see that because these are made out of pieces, there's empty spaces in between them. They're packed as close as they can get, but still they can't take advantage of all of that space. Now next to them, I've also got 1 cup of some other pieces. These are dried out rice grains. They also have some empty space in between them because of how they've stacked. A little bit less noticeable, but it's there. Now if I pour my rice in with my chocolate malt balls, you can already see that it's starting to find the spaces in between the chocolate candies, and it's starting to pack closely in there. This is something that is very distinct of material that's made out of pieces. They can closer pack because of the empty space that's in between them. Because of a difference in size, as we shake it up, we can see that they've taken maximum advantage of that empty space. Even though I combine 2 cups together, I don't have a full 2 cups of volume when I'm done. That missing 3rd cup is representative of the empty space that was in between these pieces. Okay, so how do those ideas apply here? Let's take a look at some modeling. Alright, here's some plastic models that represent water molecules. And you can see that they would have some empty space in between them. They'll pack as closely as they can, but because they're made out of pieces, there would still be some empty space. Let's push those aside for a second and take a look at the isopropyl alcohol molecules.
Here's just two of them, but you can see that they would also have some empty space in between them as they're moving about. They've packed as closely as they can. Now if we mix together the water with the rubbing alcohol, then there's going to be some ability for the water molecules to take advantage of empty space in between the rubbing alcohol molecules. They'll pack closer together than the two separate substances could on their own.
Alright, so now that you're up to speed, let's get into it. Here's our hypothesis. Number 1. In between water molecules and in between isopropyl alcohol molecules, empty space exists. Number 2. When it's all water molecules together, they have taken advantage of all that empty space as much as they can. They're as packed as close as they can be to each other. Same thing is true with isopropyl alcohol molecules. They're as tightly packed as they can be, but there's still empty space between both. Number 3, if we take a known volume of water and a known volume of rubbing alcohol and we mix the two together, the resulting volume is going to be less than if we had just taken those two volumes and mathematically added them together. And the reason behind this is because when the two molecule types are mixed together, they're going to be able to take advantage of the empty space a little bit better than when they were on their own. Just like with our rice and our candy malt balls. So you ready? Let's go get some evidence of nothing.
To begin, start with 2 cups of water. Measure it out in your measuring cup as exact as you can get it. And then using the funnel to help prevent any spilling, pour that into your empty 2-liter bottle. Be careful about it and make sure to get every last drop that you can. Then repeat this. Get another 2 cups of water. You'll be doing this a few times. Pour it right up to the line and then get that into your empty, well, now not so empty, 2-liter bottle. You don't have to mark a line here, but I'm going to since we're halfway there. There's my 4-cup line. Get another 2 cups of water and pour that into the bottle. And then do this again. Get another 2 cups. You should, when you're done, have a total of 8 cups poured into your 2-liter bottle. Now this line you definitely want to mark. Be careful about it, try to get it right on the line, and label that with your 8 cups. Our whole mission here was to turn our 2-liter bottle into a measuring device that can measure 8 cups. Empty it out, and now the real fun begins. Now you don't have to do this next part, but I'm going to add some blue food coloring to our next batch of water. Makes things easier to see, and we're going to have a little bit more fun with it this way too. You'll find out. So add this to your emptied out 8-cup measuring 2-liter bottle. Pour another 2 cups of water. Add this to the blue water you just poured in. And now you've got 4 cups of water in there. Should still be up to that 4-cup line that we drew before. Next, we're going to add in some yellow food coloring, and we're going to put our isopropyl alcohol, our rubbing alcohol, in there. Get 2 cups of this as well. Pour it right up to the line. Be sure that you're doing the correct measurements. Now we're going to add the isopropyl alcohol to our blue water. You can see that they're starting to mix a little bit, but not fully. Get every last drop. Next, we're going to add another 2 cups of the rubbing alcohol. Pour that in slowly and gently, and you should have the rubbing alcohol mostly be on top of the water. Now already, if we look at it, we see that we haven't gotten 8 cups, even though we poured in 4 cups of each. We're not fully mixed yet, so go ahead and screw on the cap of your bottle. And as you look and you see where it's starting to mix a little, well, that's where some of the empty space is being taken advantage of. With the cap screwed on tight, invert the bottle a few times and get those molecules to thoroughly mix. The molecules will be able to find the best way, the most efficient way to stack with each other. Once your solution has now settled out, we see that missing volume. It doesn't equal a total of 8 cups. That small little empty space right there means so much. It's evidence that particles exist, smallest pieces. Democritus would be proud.
I don't know about you, but I find this difference in volume to be a thing of beauty. In just those few missing milliliters is strong evidence that Democritus was correct, that smallest pieces really do exist, and that there's empty spaces in between them. That these smallest pieces, which he called atomos, that they need an empty space in order to move around. In fact, when you look at that small difference, concluding that there is a void is unavoidable. Take that, Aristotle. Now, if I just left it at that, I'd feel guilty, like I haven't really told you the whole story. Our idea of empty space, it's still evolving. We still haven't totally figured this out. In 1906, due to Albert Einstein's special theory of relativity, he laid the groundwork that would eventually verify that empty space and time are actually linked, that they are completely one thing, called space-time. It's like a fabric that really does exist, can bend, can stretch, can change. And the two are no longer separate things. And then things changed again. In 1948, Dutch physicist Hendrik Casimir, sorry if I butchered that, he hypothesized that if conductive plates were placed parallel and very, very, very close together, we're talking about just a few nanometers here, that they would have an attractive force towards each other. In 1997, this was actually verified, and it's now known as the Casimir effect. While there's many different competing explanations as to why this Casimir effect occurs, some of them include the idea that in empty space, virtual particles pop in and out of existence. That if the plates are so close, there's not enough room for these virtual particles inside of there to wink in and out. But on the outside, there still is. And those particles collide with those plates, causing that force of attraction. Empty space, as it turns out, might have a whole lot more going on than we really thought. It could be quite unempty empty space. How cool would it be to be a theoretical physicist who studies more about the void and tries to figure out what empty space is really like? You get to tell people, yeah, it's my job to just sit around and think about nothing all day. Come to think of it, I think I know a few people who already are doing that kind of freelance. Hey, if you found this lab interesting, definitely check out our 9-volt electrolysis, Indy Labs number 4. In that experiment, with just a 9-volt battery and some water, we've got more evidence that atoms exist. If you want more Indy Labs, go ahead and subscribe to the channel. We've got more on the way. You don't want to miss out. Also, do you have a suggestion for a scientific concept that you'd like Indy Labs to explore? Go ahead and post a comment below. Can't make any promises, but we will try to fill some requests from time to time. Next time you're feeling empty inside, maybe this thought will help you out. Even in complete emptiness, there are still wonders yet to be discovered. Thanks again. See you next time.
There are connections between hip-hop and science.
It's Ghostface Miller, never faking the funk, but I'm raising the bars like a high-pressure front. In the laboratory, I'll keep you safe and healthy, cause I take my precautions, then a tween take selfies. My rhymes produce the heat of exothermic infernos, to flow smooth with the friction coefficient of 0. Just like atomic plates, I'm never at rest. Style so hard, neutrinos bounce off my chest. Dropping matter, science never leave you lost. It was one DMC who said with wisdom and thought, next time someone's teaching, why don't you get taught? So come fill your head with the knowledge that I brought. Geology, ecology, astronomy. You follow me, I'm a GOG, you're in good.
Oh man, spilled all this water.